That has 8 sides.
8 sides. Right.
You may not remember it.
Yeah. It's really annoying because for my revision, I didn't look over this again.
Are
I
you
hadn't
alright?
got around to it.
Pentagon.
Pentagon, right.
Yeah.
Like the 50 pence coin. So
Yeah.
50p pence coin has that. I need to use that to remember.
Okay.
Right.
How about bottom left? Bottom right. Sorry. Do you know this one? I don't.
Bottom right. Right.
I don't
Is
think you
that a
saw.
parallelogram?
Yeah.
Parallelogram?
Yeah.
Yeah.
That's parallelogram. Those are fine. I think. Let's see. Yeah. How about this one on the left?
How many lines of symmetry does the shape? Would it have one line of symmetry going right down through the middle?
Yes, that's it.
Yeah.
Uh, let's see. So which shape up here will have 2 lines of symmetry?
Um, I would say the parallelogram.
That has 0.
All right. Um, 2 lines of symmetry. I would maybe. Would it be B?
That has 1.
One. Right. So it has to specifically cut through the shape. It can't be on the base of the shape, or right.
So it has to make it symmetrical.
Right. Um, so obviously it's A.
Yeah. So that is going down as well as going across.
Right. I see.
And so it's, yeah, reflective that way.
Right.
Okay, what's this one on the left about?
Two of the polygons are congruent. Write down the letters. These two of them. Write down the letters of these polygons. Congruent.
Do you know what congruent means?
No, I've not stumbled across that. Yeah.
Identical.
Identical. Right.
So it
Uh,
might be rotated or moved around, but it's identical.
right. Yeah. So A would be one of those shapes.
So what is it identical to?
Uh, um, Identical to G.
G has 6 sides. A has 8 sides.
So identical, not in the sense of it can just be moved or rotated, just more how many sides it has.
Yeah, so it's the same shape, but
Just the same.
it might
Right.
just have been rotated. It might have been moved to a different position.
Okay. Uh, so it'll be F.
And what is it congruent with?
2, 3, 4, 5, 6, 7, 8. F is congruent with A.
F is similar to A, but A is bigger.
Oh, right. Um, A is bigger. So is that not the right answer?
No.
Um, This
So there's only one 7-sided one. Can't be that.
No.
It's not the two 8-sided.
So it's B and H. Those are the only two.
Do they
They're
look
different shapes?
Yeah,
No.
they're not identical.
Oh, God, it's E and D.
Yeah, E and D.
Yeah.
So they have been rotated.
Right.
Okay, the one on the right.
Okay. Would it be D and C?
Well done. So they're the same size and shape.
Yeah.
Here you have to draw a congruent shape. So you would just draw the identical shape to this one.
Right. Would it matter where it was in the graph? It doesn't matter where. You just...
No, just don't draw exactly on top of that one.
Oh, yeah.
Here's the same thing. So congruent, you just find two congruent ones.
Okay.
That's fine. That's fine. Okay. How about this one?
Right. So... it's D and E again. No. Yeah, D and E.
So they are congruent. This time it says one of the polygons is similar to F.
All right. That would be A.
Yes. Two similar shapes.
Shapes would be... A and E.
So this one is 2 and 3. This is 1, 2, 3,
right.
4.
It's 4.
4, 5, 6. Yeah, that's right. It's been doubled. Yeah. So that's A and E. Okay, great. Rotational symmetry. Any idea what that's about?
I guess it's to do with shapes being rotated.
Mm-hmm.
And even whilst it's rotated, you can still see a line of symmetry. I'm not sure really.
So it's like how many times it would fit on top of itself.
Right.
If you were to spin it around its center.
Okay. Right.
So any idea about that?
So write down the order of rotational symmetry of shape B. Rotational symmetry of shape B. So is this like how many times you need to turn it to get it to its original position?
Kind of. How many times would it fit perfectly onto itself if you were to turn
it? Once. Yeah.
What if all 5 sides were the same length?
Then it would be 5 times.
Yes. What is the rotational symmetry of pattern C?
Three.
So if you were to spin it around, you could spin it until this square was here.
Right.
And then you could spin it again and it would be perfectly back to where it was. So if you did a half a turn, it would be there. And then if you did another half turn, it would go back to where it began.
Right.
And so what would that be?
So
So it can do a half a turn to be
yeah.
perfectly onto itself, and then obviously when it comes back around, it's on itself again.
So that would be two.
Yeah.
Two.
Yeah. So if it's a half a turn, then it would be a total of 2.
Right.
How do you do this?
That's the mirror shape. So you basically you take 1 point and you go 1 square. So it's like from the middle, from the mirror line, it's 1 square to the left.
Yeah. How about the red dot?
1 square to the left. So the red dot is 1, 2, 3.
Mm-hmm.
So that's from the mirrored line. It's to the left, 3 to the left.
Yeah.
And then it's down 3.
Yeah, or you could just do the green is the same thing. That's 3 stories. That's 1, 2, 3 to the left, and then what would you do last?
You just join the dots.
Yeah, that's it. Well, with a normal line.
Yeah.
There we go. Okay, you're gonna be fine. Okay, so what is A? The top one, top left.
Okay, I'm going to draw the line that is parallel to A and B. That would just be going through the middle.
Like that?
Yeah, is that not right?
No. Parallel?
Parallel, sorry. So it would just be 1 square down from A. Okay. Along the side, no?
Yes. So same direction.
Yeah.
And bottom right?
Draw a line perpendicular to A and B. So perpendicular is just straight up. So
yeah, that's it.
Yeah.
And it doesn't necessarily need to be through the middle. It could be anywhere as perpendicular.
Right.
So long as it's a right angle. Okay, how about this?
Cube. I've never done this before. I have no idea.
So a cube that's been flattened, that's been like opened up. So you can imagine like a cardboard box, and they unpacked it. So this is incomplete.
Right. Okay. So, so there'd be beneath.
So how many sides on a dice?
6.
Right.
Yeah, 6.
How many?
There's 4. So we need 2 more.
So there's not 4.
Sorry, 5. 1 more. So it'll just be just 1 square next to the top one. No.
Yeah, it'll matter where you put it.
Right.
If this was to fold in like that,
yeah.
where could the last one go?
So. Would it be the bottom, like the
Yes.
second?
That one?
Yeah.
Well done. That's it. And so when you fold those, that makes a cube, and that's called a net.
And that. Okay.
Yeah. Two of these are nets of a cube. Which two?
Okay, so it has to add up to 6. So it would be.
They all add up 6.
Oh, they do. God. Would it be B is one of them?
So B is the one you just did, I think.
Yeah.
So that's great.
B. E.
E, let's see. So E, I don't think so, because this corner one creates a problem.
Right. It'd be F.
I think it's F. Yeah.
Yeah.
B and F. Yeah, great. Okay, how about this?
Just want to make the person. Another point meets B.
So if you were to fold this into its 3D shape,
Yeah.
where would P? What is the other point that P would be touching?
Right. So. It would be on the line, wouldn't it? If it where it says P, would it be sort of in the middle, kind of like when it gets folded when the points touch?
Like
I
here?
don't know.
So if you were to fold this to look like a Toblerone, the box of
Yeah.
Toblerone comes in. Where would the other corner? So P is at one corner, and what other corner would now be at that point as well? And just think about what way you would fold it.
Yeah. God, why is this so difficult?
So what way would you fold it?
So the top bits, the rectangles, they would just fold down to form like a cube or sort of column or whatever.
Yeah. So let's say this is the base. This is on the floor.
Yeah.
This.
So this will go down to form one side of the triangle. It's really hard to.
Yeah. So this would be the top. That would be like the point.
Yeah. And the triangles at the end, they would just close, wouldn't they?
Yeah.
Like, so I don't know how you explain that.
So if this folded, this one up here would go
yeah,
all the way over.
yeah.
And so it would be this point here would be touching this point here.
Oh, right. Okay.
You see what I mean? If you were to fold it upwards.
Yeah.
So,
I think so.
like that or something.
Right. Okay.
Yeah, it's difficult.
Very cool.
Okay, names of 3D solids.
3D solids. So, I know that the one at the bottom is a cylinder.
Mm-hmm.
The triangular one is a prism.
No.
Is it a prism? No.
Prism is the same all the way through. So that's the only one that isn't a prism. But they all have special names.
All right. So a cube is like a square. So but these are rectangular. They're not cubes, are they?
No. Similar idea though.
Cube.
This is called a cuboid.
Cuboid. All right.
This one.
So it's not a prism. It's not pyramid.
Pyramid.
Oh, okay.
Yeah, that's it. Pyramid. Okay, let's do these two.
Right. Write down the letter of the shape that is a sphere. So that's E.
Yeah, that one's fine. How about B down the bottom?
It's not. Is it a cuboid? A cuboid isn't a generic term for all.
No, so generically, this would be a prism.
Prism,
because it has the same area all the way through, cross-sectional area. What type of prism is it, do you know?
Triangular prism.
Great. Yeah. So a cuboid would be like a, I don't know, a quadrilateral prism or a square prism.
Right.
Name for this one?
Just the same as put a triangular prism.
It's not the same area all the way through. It gets smaller. So,
all right.
So it's not a prism.
It's not a prism. Oh, pyramid?
Yes. Pyramid. Sketch a cuboid. How would you sketch a cuboid?
So that would basically be a 3D square.
That's a cube.
A rectangular?
Yeah, it's a 3D rectangle.
Right.
So one rectangle, another rectangle with that where its corners in the middle, and then join them up.
I see.
Okay, here is a triangular prism. Number of edges. Any idea about that?
Okay, so well, there's the triangles. That's 6, and then 6, 7, 8, 9 edges.
Yeah. Number of faces.
2. 4 faces.
Don't forget the bottom.
5 faces.
Yeah. Let's see. Okay, the one on the top right.
Cuboid has Um, 6 faces.
Yep.
Keyboard has 6 faces. Edges. Um, 8.
So it's got 4 at the front, 4 at the back.
So that's, yes, that's 8 and 9, 10, 12.
Yeah. Do you know what vertices are?
Vertices. No.
Corners.
Corners, right. So, in that case, 1, 2, 3, 8 corners.
Yes. Well done. I might come back to that if I need to. Let's do top right. Let me just, yeah, do top right one.
Okay, write down number of faces. So, 5.
Yep.
Edges would be 6 edges.
So I believe there's 4 on the bottom.
Oh, 10.
So I believe there's 4 on the bottom, and then you can see how they go to a single point.
Right. So 1, 2. Gosh, this is so confusing. One, five. Would it not be 5?
It's definitely not 5. So I see 1, 2, 3, 4, and then the diagonal ones going up. So that's a 5th,
Right.
6.
Right.
So there's basically 4 on the base, and then 1 at each corner. So 4 more that go up to a single point.
Right. I got confused. I was looking at the corners, like the points.
Ah,
That's what I
okay.
was adding up. That's why I did that wrong and got confused.
So vertices is 5. Yeah, you're correct about that.
Right.
Let's see. So you think you'll be fine there. That's okay. So we did that. I think you're okay there. Okay, top left.
Okay, draw a sketch of a triangle, a rectangle.
So I think you know how to do that. And B.
Yeah. B. Write down a mathematical name for the straight line. Is there a diameter?
It would be a diameter if it went through the midpoint.
Segment?
No. Looks like a guitar string.
No idea.
Chord.
Oh, chord.
Yeah. Top right.
Rectangle. Shared region. That's a segment, isn't it?
Segment's kind of like the crust. This is like the slice.
Oh, it's not the core.
You may not know it. Sector.
That's it, yeah.
This one bottom right.
Straight line inside the circle goes. That's the diameter.
Yes, that's great. Any idea of the name of this line? It touches the circle at a single point.
God, we did actually do this, I think. Totally forgotten.
Tangent.
Tangent, of course.
Okay, top left, draw a sector.
Draw a sector. So a sector would be not like a slice. It would be, oh no, yeah, it would be like a slice.
Yeah.
So yeah.
Top right.
Draw a radius. So that would be halfway to the mid.
Yeah.
X.
And bottom left.
The chord would just be the line going across at the sort of the corner, sort of not through the middle, basically.
Well done. Yeah. If it goes through the middle, it would be a diameter.
Yeah.
Something like that. Okay. What would be bottom left?
Right down. Straight. Oh, that's the tangent.
Yeah. Okay, top right.
The rational. Rotational. Rational. Rotational symmetry. So, rotations.
So if spun around its center, how many times would it fit perfectly onto itself?
Oh, 3 times.
Yeah, that's it. Because it's equilateral, all sides same height.
Yeah.
Okay, let's do top right.
Okay. Find the area of the shape. So that's just basically adding up all the sides. So it's 2 plus 1 plus 1.
That's perimeter.
No. Oh. Find the area. Oh, so. Oh, I get it. So it's 2 times 4, and then take away 2, so it'd be 6.
Yeah, and you can see there's 1, 2, 3, 4,
Yeah.
5, 6. How about the perimeter of top left?
Top left. So yeah, there's 4 squares up. So 4 plus 3. 4 plus 3 plus 2 plus 5 plus 2 plus what is that?
I think it's 8. Yeah, I think you'd be fine for working that out. Plus 8. What about its area?
So basically that's going to be 4 times 3 is 12. So adds up to 12 for the left if it's a rectangle. The left side. and then the other side would just be so what's that? So it's 10. So 10 plus 12, 20, 22.
Well done. And that's 10. That's 22. Okay, that's fine. What would be the perimeter for shape D?
So that would be 3 plus 3 plus 3 plus 1 plus 2 plus 1 plus 2 plus 1.
Okay, you're good, and so on. Okay.
Yeah.
How about this one?
Okay, so right, so this is height times width. So it's the perpendicular height, which would be 2. So 3 times 2 should be 6.
Correct.
6.
Yep, 3 times 2, and so it's 6. So it's like a rectangle.
Yeah.
It's parallelogram. You find the same way. Indulge me. What's the perimeter for top left?
Okay. Top left. That's 5. 5 plus 2 plus 4 plus 1 plus 1 plus 1.
1, 1, 1. That's fine. And area, you're gonna be fine there. Okay, volume.
Okay, so 2 times 2. Um, 2 times 2, 4. Would it be 8?
Yep. So volume is thousands. We don't need to do that. Faces, vertices. Okay, how about this?
Okay. How many minutes? Guess the supermarket. Leaves the supermarket. So 15 plus 10 is 25 minutes.
Yeah, and so my conscience is clear for all of these weird things.
Yeah.
Hang on, what temperature is that?
37.2.
That would be if there were 10.
Right.
There's only 5 lines.
So is this 5 between so what's meant to be 1? I mean, what's 1?
So that's a good point. So what are they going up in if 5 of them makes 1?
5 of the next one. So 5 divided by 1.
1 divided by 5.
Sorry, 1 divided by 5.
And so basically, instead of it being 0.1 for each,
Yeah.
it would have to be double that. What is double 0.1?
0.2.
Yeah. And so, what temperature is it?
0.4. 30. So it's not a point. There's no 37 point something.
Yeah.
It is 37.0.2.
So this here would be 37.2.
Oh, so it'd be 37.3.
They're going up in 0.2.
Oh, sorry, 0.4.
Yes.
37. Right.
So if there was 10 of them, they'd be going up in 0.1. There's only 5 of them, they're going up in 0.2.
Right.
This one on the left.
Okay. Right down temperature. This one's such a nightmare. Right. So between 200, 250. 1, 2. One, 3, 5, 50 divided by 5 is 25.
50 divided by 5 is 10.
Oh, sorry.
So there's 5 of these from 200 to 250.
Right.
50 divided by 5 is 10. And so that means each big line is worth 10. They're going up in tens.
Right. So it'll be 240.
Yeah. 240. Let me just see what so those are just timetables. Yeah, let's just do part A.
Right. What time does it get to around? What time should this get to around? What time should this get? It's not 9:08, is it? I mean,
Yep.
It says 9:08. Yeah.
So it's just showing that you know that it's going downwards.
All right.
That's okay. So how about part A for this one? No, hang on, not that one. Let's go back a second. Nah, so they're all very, very similar. Okay. Fine. Okay. How about this one?
There's you guys for check-ins. Right down this way. So, this is like the other one before. So, 2, 4, 6, 8.6.
Well done. 8.6 kilos. Okay, we're gonna be fine there. Hang on. Okay, how about this one here?
Okay. Okay. Yeah. Chinese burning. I should just try everything. So, Birmingham to Coles Hill is 12 minutes, and then I see. So from 7 o'clock, so from to Leicester, 17 minutes.
Are you doing part A up here?
What time should it get to? The train leaves Birmingham at 6. Oh, 3. Oh, I'm looking at the wrong one. Sorry, it's 7:29.
Yeah. So long as you know how those work,
All right.
they go down. You can figure out how many minutes does it take and all that.
All right.
You can see it's a very, very common exam question.
Yeah.
Okay, what's this about?
Measure and write down the bearing of airport A. A. B. Bearing point. Bearing of a point.
Do you know what that refers to?
Bearing. Write and measure down the bearing of airport A. B. No idea.
It's like the angle. So, of B from A is the same as from A to B.
Right.
So from A to B, the angle that they're referring to is this angle here. So this is bearings. So you point north, you turn clockwise, and you stop when you hit the line. In this case, we measure the angle once we have the angle. Measure it with your protractor. Turn clockwise and stop at line. They're always presented in reverse. So of B from A. So you do from A to B. Protractor.
Right.
Hang on. Okay, so you put your cross on the X. You turn it so that it is 0. So north is 0.
All right.
And so what does it look like the bearing is?
Like 58-ish or...
Okay. Bearings have 3 significant figures, And so, strangely enough, you write your answer as 058.
All right.
So that's there. And so, answer 23 sig fig.
0,
So that's 58 degrees. And so that's 158 degrees as a bearing.
Right. Okay.
So this one, work out the real distance. The scale is 1 centimeter is 1 kilometer. So I can't do a ruler with this stuff. From Hitch to Longford. Yeah, Hitch. So you just draw a line, measure it, and whatever it is.
Okay.
Right, in kilometers. Hang on a sec. Okay, how would we do this one?
Measure and write down the bearing from B town B of town B from so like before, you go to B, get your protractor, make sure the 0 is on the north.
This one, is it?
Yeah.
So
it's going anti-clockwise, isn't it?
Yeah, so if they wanted that, then it would be this angle here.
Right.
I suppose you could just do this one and do 360 take away. Right. It says of B from A.
Of B from A.
So that means from A to B.
Oh, from A to B.
So from A to B.
So it'd be the other side. It will be the going down.
So that's the angle you would measure, and this one is more than 100 degrees, so it would already have 3 significant figures.
Right.
And there's more bearings and stuff. I'll just do a quick recap. Name. No, we're good there. You'll be fine. How would you do this one?
Okay, draw the shape. Just literally draw a shape identical to it on the other side.
So that's 2 diagonals.
Yeah.
That's 1 right, 1, 2, 3 down, and the third side, the last side, you get for free.
Yeah.
Pair of congruent shapes.
So the D and B.
Yes. Great. What is the bottom right?
Bottom right. A cuboid?
Yes.
Yeah.
It's cuboid. What is shape D?
A pyramid.
Yeah. Shape C is has a circle at the bottom, and so that's a cone.
Cone, right.
Yeah, we didn't get to see that one.
Yeah.
They just didn't ask about it. Okay, bottom left.
Bottom left. How many faces does shape B? So, 6.
Yeah, and next one.
How many edges does the shape D have? The edges. 1, 2, 3, 8.
Well done. You had difficulties with that one before. How about the bottom left?
Move vertical vertices. 1, 2, 4, 8.
Well done. Vertices are corners.
Yeah.
That's fine. Top left.
Top left. That's a chord.
One on the right.
Segment.
No.
Oh shit. It's not a segment.
Sector.
Sector. Oh,
Yeah, just try to remember it.
yeah.
I just want to see. So perimeter and area, you're fine.
Yeah.
And then maybe just rotational stuff. So what I recommend is you go through the book, just do every question now. If you're stuck on anything, make a note of it, take a photo of it. You can email it to me, and do it that way.
So when you say the book, are you referring to everything's in the email?
Like do you have a maths book or anything? I remember you were using the maths book before.